Yeah.
So we now have Manny, and he'll be presenting on the Draco helipod.
Okay. Thank you very much. My name is Mani. I'm a research software engineer at Helmholtz-Zentrum Dresden-Rossendorf. This is an institute in the outskirts of Dresden, and almost every large building that you see here is a large-scale facility. And you can see some of the facilities somehow isolated, like behind this green wall. It's recommended to be athletic, not because it's far away from the entrance, but because they are working with molten sodium to see the magnetic effects to understand magnetic effects. So if something happens here, the lab fills with nitrogen or argon in a very short time, and so you just have to run out of the lab if something happens. But so this is the kind of experiments we are doing at ZDR, and Oliver gave a brief description of other experiments. Okay, I'm going to talk about Draco. This is a more convenient experiment. It stands for Dresden Laser Acceleration Source. It's a state-of-the-art, high-power, ultra-short pulsed laser system, which can deliver pulse energies from 6 joules to 45 joules at a pulse duration of about 30 femtoseconds with a typical frequency of 1 to 10 hertz. And in this experiment, the beam characteristics are recorded, so the shape of the laser beam, in form of images and several instrument parameters. So this is the Draco team, and we have a technical side and a scientific side. On the scientific side, headed by Hans Peter, the scientific side or team is interested in what happens to a target when it is being excited using a laser. So they are more interested in the dynamics of the electrons and other things that happen to the material because of heating. And then we have a technical side, which is headed by Stefan Bock, who is only interested. He's a technician, and he's only interested in having stable lasers, so having a good beam characteristic and things like that. And the way this setup works is that we have a laser beam, which is then splitted at some point, and you look at the laser beam using detectors, and you store this information, the beam characteristic, the shape, and how the energy profile is in the X and Y direction in a non-persistent database, a Draco database. And the images that are being recorded here are stored in the raw format in this Draco database. So far, so good. But as it is in the scientific world, many of these things are written by PhDs, postdocs, or sometimes even companies. And when the person leaves without writing a documentation, you can do all these things, but you don't know how to use the data in the database. So this is exactly what's happened there, that all this information about this beam characteristic is stored here in some format, in some way, but nobody knows how to use it. So they came to us with this data. So certain tables with only information that they can make out what actually this particular entry is, because it is a little big, that this is the image in the raw format. But they couldn't even tell us what is the size of this image. So there is all the data present in this database, and this experiment has been running for years, but they can't use the measurements that are here. They can give us some information, okay, these are the devices. There are some measurements in integer format, in double format, and things like that. So then we had a master student who looked into search for the patterns in this table and came up with this idea. He said, let me just connect the tables. Let's see if there are some commonalities in these tables. He came up with some cool ideas of connecting the tables using the shot counter ID and the origin ID. And then we found out some patterns, and we found out that the top origin ID must be a device. The origin IDs are the measurements, these are the names of the measurements. Some measurements are in integer format, double format, and the images are correct. We found out the size of the image also using artificial intelligence or brute force. And we also found that there are certain things which they didn't knew are also measurements. They were discarding it, but these are spectrums. So so this master student found out a lot of patterns in this data and was able to structure the data according to data types, according to the size and everything. And then he came up with a clever plan how to curate the data or structure the data, that we have certain runs, and these runs have certain shots. Shots are a series of pulses, and these shots can be characterized using measurements, which are in these different formats. And you can add the device information and the measurement information to these shot counters. But still, even though we have done this data acquisition and we have been able to structure it, there are a few things that are still work in progress. For example, the device name resolution in some cases doesn't work. Or sometimes the shot counters are not a number. So shot counters have to be integers, but they are somehow captured as not a number, and we have to talk to the experimentalists what actually is going in the background. Anyway, finally, after a few years, we finally have been able to show the experimentalists exactly what they are measuring, what they have done. So this information, how the beam size was, and how for example, here the spectra of one particular run with many different spectrum, how the energy profile of this beam is evolving. We were able to show it the first time after a few years. So this was a cool thing done by the master student. Okay, so I have been talking about this data acquisition, and the further steps that we want to do now, which is now a work in progress, is we would like to take this data, use compression algorithms, also develop certain intuitive relations, and then feed all these things into our services at HCDR, into a persistent database, a Mongo database. And since master students are very creative and very motivated, these are some ideas from our master students to develop or use existing ontologies for this data, use some structure graph and knowledge graphs, and I hope he makes progress in this direction. Okay, Oliver gave a brief description about our heliport project. We are currently also, we already have the structured experimental data as it is, and we would like to enrich it with metadata for heliport, for example, add information on like beamline information, sample techniques, the project proposal metadata, even the data location. And we also have an incubator platform which is doing machine learning, and we are currently discussing with them to include metadata for machine learning experiments. So in particular, beam characteristics, so that they're able to control the beam characteristic in real time during the experiment. So as I showed earlier, that the experiment, so this technician are only interested in creating a laser, and the scientific guys want to control the characteristics of the beam, which is not possible until now. So this AI team would then try to control the beam characteristic in real time during the experiments. And this is how the whole ecosystem would look like, starting from the Draco setup towards heliport, and a few other functionalities like visualization in Grafana or data publication. And with that, I would like to conclude and acknowledge all the people working behind this project, and also the EU projects that are funding this experiment.
We have time for some questions. There's a hand up in the back.
sure that, like in 5 years, the same problem doesn't arise again? I think there are not many. So I think there can be many answers to this question. My approach is to first that we found this problem is to present the experimentalists with a very stable solution. This is my first approach. And once they see that these kind of things work, then better they would at least be motivated to include, let's say, the data management group from the beginning, and that's our hope.
So actually the situation you describe is pretty strange for me. And the question is, so the guy who did his PhD apparently published some papers. So in the papers, the metadata should be described.
Yes.
So can you leverage that information and just look into the publications?
The main guy who wrote this code, this data acquisition to the Draco database, he was actually working at a company. And he left before writing a documentation. That was one problem. And the second thing about the PhD student, he just wanted to finish in those 3 years. So he just wanted to do some experiments. So instead of recording these experiments, he said, let's just shoot the thing 100 times or maybe something, and then let's get the best results. It's not best practice, but this is what happens.
You know, what you write in your paper, I shot 100 times.
No, you shot 5 times, and these are the results, something like that.
Yeah, you need to say what was the setup, what was the beam.
I'm very sorry. I was not that. It is this project is 5 years old. If I would have been there, I would have. If I would have been the referee of the paper, I would have asked him how many times did you do the experiment? Is there metadata? But yeah, we're working towards that goal.
We'll hold you to that then when you're referees. Okay, once more, thank you. Thank you.